Hello friends, welcome back. Today I'm going to go through the map the debris intermediate algorithm scripting video. So we want to return an array that transforms the element's average altitude into the orbital periods in seconds. The array will contain object in the format of an object with two key value pairs, name with a string attached and then the average altitude with a integer attached. You can read about orbital periods on Wikipedia. Now I did read about orbital periods, and this is exceptionally difficult to understand, especially if you haven't had a strong math background. And so I'm going to go through this in a way that makes it so you don't have to understand the math essentially. It's not really necessary that you know how to translate Kepler's third law into algorithm scripting for the purposes of being able to write web applications, in my opinion. I think that this is really difficult, and it doesn't necessarily build the skill of being a programmer. It's more of figuring out something that's very challenging. So let's see. The values should be rounded to the nearest whole number, and the body being orbited is Earth. So they're saying we're going to do this for Earth, and the radius of Earth is this, and the general mass or whatever. What was it? Semi-major. The GM, which is the standard gravitational parameter, is this number, which they've saved for you over here. You can see them here and here. And so let's see. The first thing we want to do is say, let's console.log the orbital period. So this gives us what's being fed back from when you feed this parameter, when you feed this array into orbital parameter. So right now we're just doing a single array. Now I notice that there's only one element of this array, and whereas there's more than one element here, there's three elements here. So I'm just going to immediately begin programming from this end state. So I'm going to copy this and paste this into here. As always, I like to keep my code organized and clean so it's easy to read. Yeah, and so this makes it so it's pretty clean. So right now, we're passing into the orbital period, this function, we're passing in this array, which we're feeding back out. We're just saying we're returning the array. So the first thing I want to do here is say, let the result, the radius of the values should be rounded to the nearest thing. Return a new array that transforms the element's average altitude into their orbital periods. So orbital period results. So we're making an array so that we can take this from this array. We're going to pass in all the return values from the data that's being passed in. So the thing that we want to do is save the name, but we want to convert the orbital period into a different integer, and we're going to run through there. But the first thing that we can do is just construct the orbital period results array. So now we're passing in an empty array. So what we want to be able to do is iterate through this array. This array has a length of 3, right? 1, 2, 3. And so we want to do an each loop to iterate through each of these. So we're going to take array.forEach, and then we're going to do a function where we pass, and then the function is going to have I'm going to call this a data point. So if we were to now go into here and do console.log data point, we're seeing we're printing out, this is the first time through the thing, this is the second time, and that's the third time. Now if we did datapoint.name, it would just pass ISIS, Hubble, and Moon. So that's pretty useful because we know we want our orbital period results to have a key value pair of the name. So we can say our orbital period, first off we need to make our, what's it now? Our translated data point. And we're setting this equal to an empty object, right? And so our translated data point dot name is equal to our data point dot name. Okay, cool. And so now if we were to console log translated data point dot name, we're getting just the names here. And so, yeah, what we want to do is translated data point dot name. If we set that equal to the translated to data point dot name. Okay, so we're creating this translated data point, and then we're saying the name is the data point dot name, which is the name being fed in. And so we want to say, now here we want to push in the results, right? Orbital period results, and we want to push the name, the translated data point. Okay, cool. So now what we're doing is we're iterating through, and with each one we're taking the name and assigning it to the name object key, and then the value we're passing in the name. So now we're already going name ISIS. We've already got name Hubble and name Moon. We've already got these guys being copied to our resulting data point. So now what we want to do is say our translated data point dot, what are we looking for? Orbital period. And it's important to name it exactly orbital period, I'm guessing, for the test. We want to make that equal to, let's just call it 22 for now. Okay, so 22. So now we're passing it in. Now our orbital period here, 557, 5734. We know we need to make a calculation, but we're getting an array with 3 objects in it that have name and orbital period as the key value pairs. So now all we have to do is change 22 and make it so that it is resulting from the difficult program that we have to figure it out. So I already created that over here. So orbital period is equal to 2 times pi, and then square root, and then we need to do the square root of the Earth radius plus the average altitude cubed divided by the general gravitational mass, which is really confusing. So let's just break it down initially. We're trying to get the orbital period, so we could start off with 2 times pi. That's easy to get, right? So we can say let 2 times pi equal, and the way you get pi is math.pi, and then you just multiply that by 2. So now I just like to see if I'm doing it correctly. I'm going to console log this. 2 times pi is 6.243, so we've got that part correct. Okay, so we've got 2 times pi. Our next thing should be, we should get Earth radius plus the average altitude. So yeah, let Earth radius plus average altitude. Okay, so Earth radius, we have this guy, and then we want to add that. Well, where's our average altitude coming from? That's coming from our object, right? So we're getting fed through, for each of the objects we're passing in a data point, and we want to say the data point dot average altitude. Well, yeah, data point dot average altitude. Okay, I'm just going to pull this out. Cool, so average altitude. Average altitude plus Earth radius. So this guy, we could say the top of divider. We're going to make that. Now, what am I saying? The top of the divider. Earth radius plus average altitude. The top of the divider. So the result of this is equal to this number cubed. And so to get that, we need to do, well, no, it's going to be to the power of 3. So we go Earth radius plus average altitude to the power of 3. That's how you do that in JavaScript, the double star. And so the top of the divider should be this number if we console log. Data point is not data point. There we go, data point. Okay, top of divider is not working. 3 cubed. Huh. How do you do power in JavaScript? I think it's math.pow, and then you pass in 2 numbers. Well, we could just do this. Now, we don't know, we know that cubed, it just means that it's times 3, right? Or it's multiplied by itself times 3. data point dot average out. Okay, so maybe I'm doing something wrong here. Data point dot average avg. What is it? avg capital ALT. Data point. Data point is not defined. Orbital period. Oh, okay, so in here, I'm passing in the wrong thing. What I'm passing in is the result, and we need to pass in the question. So I'm just gonna do it like this again, but this time I'm making the key average out. I hope that makes sense. What do I mean when I'm saying that? Well, I had copied this guy, which was the result, and so the average altitude was not being listed in there. And so here, it is being listed now. So now we have an array with the three objects that are being passed in properly rather than the result. So yeah, Earth radius plus average altitude is equal to element times average altitude. And then the top of the divider is equal to the top of the divider. Reference error. Data point is not there. Data point. Okay, I changed it from data point to Ellie, but I'm going to change it back. Data point. And then here we also have data point. Okay, cool. So now we're getting individualized numbers times cubed, top of divider cubed. So that gives us, so if we look at our equation again, this is the top of our divider. This is what was inside, and then we're cubing it. So we've got the top of the divider here, and we want to have the bottom of the divider. The bottom of the divider is just GM, which we already have. So that's, we don't actually need to re-add that in here as a variable. But what we could do is we can start saying, we can say the number to square, right? And we're going to make that equal to the top of divider. Yeah, the top of divider divided by GM. Okay, so I'm going to go over that again. Earth radius plus average altitude we get here. This is the Earth radius. Oh, and I shouldn't have it be the same number. I should be like Earth radius because they give us the variable here. So Earth radius plus the data point dot average altitude. So that means we're going through each one and we're saying this number. We're saying this number plus 413. And that gets us the Earth radius plus average altitude. So average altitude is 413, and we're adding that to Earth radius. So 6, 7. So okay. Average altitude 413.6 plus 6,367 is equal to 6,781. Average altitude 556 plus 5367 is equal to 6924. And then the last one is the orbital period. The last one is the moon, which is much bigger than the Hubble and the ISIS. And so the moon is this 378,632 plus 6,000. So that's going to be like 38.5. Okay, cool. So that's what we're getting. So that is equal to the top of, that's equal to, so that's how we're going to get the Earth radius plus the average altitude. And now we're going to cube that. So we're going to times it by itself 3 times. And then that gives us the top of the divider, which is something I'm calling. That just means it gets us this guy, the top of the divider. So this guy divided by this guy gets us the number to square. So the top of the divider divided by GM is the number to square. The top of the divider divided by the GM is the number to square. So now we have 2 times pi and we have the number to square. 2 times pi and the number to square. So we need to take the number to square and square it. So the squared result is equal to math.sqrt square root. This is just the JavaScript thing. And yes, I looked all this stuff up before I I found the answer to this. This is my second time going through this because I struggled with this a lot. And it's because of the really intense sort of geometrical math that goes on in this. And I mean, in terms of just assigning it to an array, which is what you really want to learn, that's kind of the most important thing. But anyways, the square root of the number to square, right? That is the squared result. So right now, this whole portion right here is the squared result. So the squared result times 2 times pi is going to be equal to the orbital period. So we've got 2 times pi here, and we can say we're going to let the orbital period result equal 2 times pi. Okay, we're going to make that times pi. 2 times pi times the squared result. Okay, cool. Now the orbital period result gives us these numbers, right? The top of the divider. We don't need this anymore. Let's go console.log the orbital period result. Okay, so this gets us the numbers, and we can see 557, 5734. That's pretty much right, but we've got all these trailing numbers. What do we need to do? We need to round it, right? Well, I think we can do that in the next one. The translated data to the orbital period result. So this is the orbital period. We want the right answer in here. So we can take all these numbers and put them into here. So the orbital period result, and that what we want to do is say math.round. That's the JavaScript to round things. And then our final result has what looks to be the right numbers and everything like that. Okay, so I'm going to delete this. And there we go. This is one way to do this problem. This is an exceptionally long one. I think a lot of people would say that this isn't a great way to do it because, I could refactor it to do cubed, right? Yeah, so the way to look that up is we go power math.pow. I go back to W3 schools, look it up. Okay, so to get 4 cubed, you say math.pow 4 cubed. So what we want to do is say our number cubed. So we could say math.pow this number, and then we want to go cubed. Okay, cool. So that's a way to refactor the top of the divider. The top of the math.power. Okay. Okay, so that's the top of the divider. Let's see, what else could we do? This is the top of the divider, right? Well, instead of saying Earth radius plus average altitude, we could scale this back and then just throw this guy in here. Okay, cool. So that still gets us the top of the divider. Really, the top of the divider is just this guy, and we could actually save some time by not doing this here at all, and then just throwing it in top of the divider. Now, I don't even like that. I think that it makes it harder to read. But look, we're going to do that. I'm just trying to show you guys how you can refactor code. So 2 times pi, here we're doing 2 times pi, but we don't really need to do that by saving a variable. We could just say 2 times pi and then put this in brackets. Because of the order of operations, we want to make sure that we're going to 2 times pi before we multiply the result of 2 times pi by the square result. Yeah, so this is a way. Already you can see this function's getting much smaller. I'm sure that there's some way that we could use that one JavaScript thing where you say the name and then the period and do that, but I'm not really going to want to do that for this one. So yeah, I think if we run the test, this will pass. So yeah, the idea here is just that we're iterating through and we're saving the name to an object, and then we're also figuring out the orbital period. I mean, one thing that you could do if you wanted to is that you could just say like calculate data point from this orbital period situation. So I would extract this into a function if this were in a real application. All of this stuff that's in between here is all dependent on this single variable, and all of this is the same thing. So I would actually extend this into a function called calculate orbital value, or orbital period. And then we want to just pass in a number. Okay, and so this isn't a separate function, right? And so what we would want to do is, for the number, we're just, translated data point. Orbital period results push here. Okay, we're just going to pass into the translated data point, to the orbital period, we're going to pass in, I'm going to add a comment here just so I don't lose this math.round. And we're just going to say calculate orbital period. And then we're going to pass in the data point dot average altitude. So we're creating a function where we just pass in the we're just passing in a number, which is the number that's associated with this one. It's in this example, it's 4136, it's 5567. If we pass this in, then we immediately just get the result of the orbital period. Okay, cool. So math.round. I'm going to take this guy back out of here and put it down to here. We want to return this guy. Now it says orbital period results not defined. So yeah, we want to move this guy from here to here. And now it says the squared result is not found. Yeah, okay, cool. We want to move this from here to here. And now it's number to square is not defined. Okay, cool. Number to square here. We want to move here to here. The number to square. But now it says Earth radius is not defined. Ooh, okay. I didn't think about that. Calculate orbital period. Okay. We're going to say calculate Earth. Orbital period around Earth. Because this function specifically works to calculate the orbital period around Earth. So calculate orbital period. Now it's telling me that this one isn't right. Around Earth. And now what's it saying? Data point is not defined. Well, our data point here isn't defined because it's not in the array. So what we're doing is we're passing into this function here, we're passing in a number. And that's what we want to be this number. So what we want to do here, as we call this function, the number that's being passed in is data point.averageAlt, but we're saving it as a parameter of number. What is it specifically? It's the average altitude. So we should say average altitude. So this creates a parameter in the function that we can just pass in here. Okay. And then also we want to change the GM and take it out of the orbital period and put it into here. Because what was it saying? What was it saying? I need to go slower than that. GM is not defined because we're using GM only in calculate orbital period around Earth. So I would take the GM out of here and put it into here. And that has to do with scope. If it's outside, if the scope is outside of, if we're dealing with a variable which is defined in here, but we're extracting the function out to here, then the GM, which was in this function, was not included in this function. And so now we are getting the right number again. Instead of having all that crazy math in the for each statement, we've extracted it into a function which specifically does what we want it to do. This might seem completely crazy to non-programmers. Once you develop a bit more understanding of like why we separate concerns like this, like why do we not want to do all that math in this orbital period function? This should be more like assign orbital period values, and then this just always just runs the math. At least that's the way I think. The way I had it initially would pass the test and you'd be fine. This is just a way to refactor to where you can kind of get an idea for how I think about code. But yeah, this does pass the test. And that's pretty much it. This is a really tough one. I think that the complexity around figuring out this function is actually needlessly important, because really what we're trying to do is just bring in the data, iterate through the data, assign it to values that we want as outputs, and then return that output. So that's what we do here in this function, and then this is just the annoying physics big math problem that scares a lot of people away, when in reality mostly what you're doing in programming is calculating and assigning data and feeding it the proper way. Anyways, that was a big one. Hope you guys enjoyed this one. Thanks for watching, and we'll see you in the next lesson.